What is sex-linked inheritance? Sex-linked inheritance is an inherited trait controlled by a gene located on the X and Y chromosomes, otherwise known as sex chromosomes. Women are the only ones who can carry a sex-linked disorder or trait because they have two X chromosomes. For example, if a woman has a dominant allele for healthy vision and an allele for colorblindness, she is a carrier for the disease. If she has two recessive alleles for colorblindness, then she has the disease. Men are more likely to have a sex-linked disorder. This is due to the fact that they have just one X chromosome, and the X chromosome is what determines whether or not they have the trait or disorder. Let's look at a pedigree of a model family. Marie, the wife and mother, doesn't have hemophilia, but her daughter was born as a carrier of the disease. Let's figure out her father's genotype to see if he passed it on to her. If we do a Punnett square with Marie and her husband, assuming he has hemophilia, we can see that their daughter would have received the allele from her father. Two normal vision parents produce a colorblind son. Draw a pedigree that includes every person, 3 people, mentioned in the story. Include a Punnett square of the parents. Okay, so we know that the father has normal vision, which means that he has a capital B allele. So since the son still turned out to be colorblind, we know that the mother must be a carrier for colorblindness, meaning that she has the capital B for not colorblind, but she also has a lowercase b allele for colorblind. So if we go ahead and draw out our Punnett square, so we see that the result of their Punnett square shows that they could have a colorblind son. So now if we move on to drawing a pedigree of their family, we draw the square, which represents the father, we draw the circle, which represents the mother, and we can actually shade that circle in because we know, not all the way, but just kind of, scribble over it to represent that she is a carrier for the disease. And then if we go ahead and draw the square that represents the son, we can shade that in because he has the disease. And then if we go ahead and write their genotypes next to them, next to the father, we can write X capital B Y. Next to the mother, we can write X capital B, X lowercase b. And next to the son, we can write X lowercase b, X Y. Okay, so we already know the genotypes of the parents are X capital B, X lowercase b for the mom, and the dad's genotype is X capital B, Y. And then next question, what are the chances of their next child being a colorblind daughter? Well, if we go back and look at the Punnett square, we can see that there's a 0% chance of their next child being a colorblind daughter. Their child could be a carrier of the colorblind disease, but it's impossible for them to have a colorblind daughter. Okay, so the last question is, before having this child, what was the probability this couple would have 3 children all healthy? And so we know that if we look at the Punnett square, we can see that 3 out of 4 of their children were healthy, even though one of them would be a carrier for the disease. And we're trying to figure this out for 3 children, so 3 times. So we would do 3 times 4 times 3 times 4 times 3 times 4. And that equals 27 over 64. So there's a 27 in 64 chance that before they had their first child, they would have 3 children who would all be healthy.